Hello GCP students, so today we're looking at composition of air and lung volume. So this is very, very simple, the composition of air. Inhaled air that we breathe in 78% oxygen, nitrogen, 21% oxygen and 0.04% carbon dioxide. What we breathe out is 78% nitrogen, 16% oxygen and 4% carbon dioxide. So the difference between inhaled and exhaled air. How does the percentage of the different gases vary between inhaled and exhaled air? Nitrogen remained the same, so we don't use nitrogen at all in the body. Oxygen levels have gone down because we've used oxygen for our muscles. And carbon dioxide levels have risen because our body produces carbon dioxide as a byproduct of aerobic respiration. So the nitrogen, the largest percentage of gas, the same amount is breathed out as is breathed in. Just we don't use it, as we just said, carbon dioxide moves there as well. You've got to be able to recognize these figures. Okay, so state two reasons why the level of nitrogen remains the same in inhaled and exhaled air. The level of nitrogen remains the same because it is not being used by the body, and therefore we breathe in the same as we breathe out. Okay, the next thing we're going to look at is the lung volumes. So you need to make sure you know the difference between tidal volume and vital capacity, as well as the reasons for changes to tidal volume as a result of participation in physical activity and sport. Lung volumes refer to the capacity of the lungs and how much air they can hold. The greater the volume of the lungs, the more air they can hold. That's lung volume. Tidal volume is the amount of air inspired or expired, exhaled or inhaled in a normal breath. When our bodies are at rest, breathing is slower and shallower. When we begin to exercise, our tidal volume increases because we breathe deeper and we breathe faster. During exercise, you need to increase airflow into and out of the lungs because you need to get more oxygen into your lungs so it can diffuse into the bloodstream for additional energy production, and you need to breathe out the additional carbon dioxide that are being produced by the muscles during exercise. By breathing more deeply when you exercise, you inhale more oxygen and exhale more carbon dioxide. Okay, changes to tidal volume on the graph. As we can see here, this graph here, tidal volume is here, vital capacity. Now, vital capacity is the maximum amount of oxygen, maximum amount of lung capacity you have. So this is how much your lungs can possibly expand. Tidal volume is what you're using at that current moment. So tidal volume will increase as you exercise, but it can never increase above vital capacity. Vital capacity is the maximum level that your lungs have. If you're breathing as deep as you can, vital capacity is that limit. Whereas tidal volume is what you're using at that moment. But the tidal volume can never go to vital capacity.